Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Next installation in our tutor 101 about vectors, because not understanding vectors will not allow you formally and on minimum basic level will not allow you to understand dynamics. So we talked a lot in the previous installation about the sine function, about cosine function, how they look, that those are sine and cosine and those are the same and shifted. And we talked about magic angles like 0, 90, 45, 30 and 60, and we obtained some observations. I want to talk a little bit more about that, so it will embed deeper in your brain, and I didn't want to make it overly long. So let's look on this triangle once again, and let's say that this triangle we can do Pythagoras theorem. Hypotenuse equal ax squared plus ay squared, right? Now we can put this and this. We can say a squared equals, instead of ax we put a cosine theta squared plus a sine theta squared. A squared equals a squared cosine squared theta. Remember, cosine theta is just a number between -1 and 1. Maybe any number, but it's a number. So if I put theta squared, I put not here, because this will mean theta 45 degrees or pi over 2 squared. We want cosine squared. And then plus a squared sine squared theta. And then we can factor a squared out, and we receive cosine squared theta plus sine. This will go away, and we have 1 equal cosine squared theta plus sine squared theta. And sometimes they write it that sine first, cosine second. It's totally irrelevant. It depends on your preference. And I believe you met this equation absolutely, but where it came from, it's the same that Pythagoras theorem. Nothing new, nothing separate, but what it tells us that whatever angle we take, if we know sine, we can easily find cosine from this equation. Move it to another side, isolate the unknown, isolate sine if you already determine cosine, or isolate sine if you determine cosine. So, suppose you know that cosine theta equals square root of 2 over 2. Well, we know theta is 45 degrees, but suppose we don't. Of course, we put it here, we have 1 equal sine square theta plus this squared would be 2 over 4, and we move it this way, 1 minus 1/2 equals sine theta, 1/2 equals sine theta, sine theta equals square root of 1/2, and it's the same like this, and it's the same like this, and we have this. And of course, you could use your calculator, cosine theta, determine the what is theta is using your calculator, and you will be done. And then you can determine sine theta if you want. and it will be exactly the same. I'm just telling you that knowing this formula can be very beneficial for you. For example, remember there was a magic angle that I talked with you last time, and this angle was 30 degrees. By the way, pause and tell me in radians what it will be. And of course you know what it will be, because if 90 degrees, this is p over 2. But 30 degrees, it is 1/3 of 90. So it means 1/3 of p over 2. And this is pi over 6. It's the same like 30 degrees. So when I will be talking pi over 6 or 30 degrees, it's the same. The same angle measured either in radians or measured in degrees. Maybe I should tell you what radians here, because I talked about it twice, and then I continue towards magic 30 degrees angle. And radians is this. If we take this, and we take this, and we take this angle, and we take this length, it's not a triangle, it's an arc. And it turns out that, for example, if this is 1 and theta, this is totally defined by the theta. It doesn't really matter. It doesn't really matter. Because if the full angle is 2 pi, this distance would be 2 pi multiplied by 1. If I put here r, this would be 2 pi multiplied by r. We know this, and ancient people knew that. And that means that if angle is 2 pi, then theta, if theta, it's about 6. So 2 pi is 2 multiplied by 3, 1, 4. So it's a little bit, so we take 1/6, and 1/6 would be 1/6 of the total. It's approximately 57 degrees. And so this would be the case when this length would be equal to this length. And it doesn't matter what sphere we take or what radius we take. What circle we take. It always would be, if this is 57 degrees, the length would be proportional to radius, this will disappear, and this would be the same length as this. So that's the meaning of radians. So now, to finish this, I will go to 30 degrees. And remember last time there was a triangle, this was 30 degrees, this was A, and this was AY, and AY over A was sine 30 degrees, and AY was 1/2. So A over 2 divided A equals sine 30, and we received that 1/2 is the sine of 30. And the question, and we also remember we got that cosine of 60 is 1/2. And that's from analyzing this triangle when we say that when we look on the sine, this is a ratio of the sides that opposite to an angle towards hypotenuse. And when we're talking about cosine, it's the ratio of adjacent side over the same hypotenuse. And if we took on this angle, adjacent side is this, and adjacent side to this is the ratio that define cosine of this angle now. And this ratio is the same, so we have that it's 1/2. In any case, let's stick with 30 and let's determine what is cosine 30 degrees is. Well, we use this. We can of course prove it again, take square from this and square from this and add them, but why repeat the same proof? It's like emptying the kettle, as I said, and we have the problems that we already solved. So we use this formula and we say 1 equal, this is square root, it would be 1/2, not square root squared, plus cosine squared of 60 degrees. This goes this way, so we have 1 minus 1/4 equal cosine squared 60, and we have 3/4 here, 3/4 equal cosine squared 60, and finally we have cosine, sorry, not 60, it's 30, I'm talking about 30 degrees. So 1/2 is 30 degrees, so this would be 30 here, and 30 here, and cosine of 30 degrees, square root of this, square root of 3/2. And you can figure out what square root of 3 is. Maybe 1.7, I don't know, but you figure it out, you look on the calculator, and so for this magic number we know sine 30 and cosine 30, and sine 30 is 1/2 and cosine 30 is square root of 3/2. And next time I will be talking about tangents. It's very important trigonometrical function, and it's also function of an angle. And we will talk about this, and then we'll talk about projections, because all of this is digression from vector projections. And I have to tell this because I will be using this a lot, and anytime you will not be able to understand it on my mechanical problems, you will have to go here and redo it and understand it, and if not, ask a question, write a comment, bring your own problem, subscribe, bell and like, and I see you next time. Thank you.